Hello student, now we'll start the miscellaneous exercise for the limit. But before that, we will see all the important formulas that we have learned when we solve all the problems from the exercise. Now see this important formulas. Limit x tends to 0, sin x upon x is 1. Limit x tends to a, sin of x is equals to sin a. That is, x is replaced by a here. Next, limit x tends to a, cos of x is equals to cos a. That is, x is replaced by a. Limit x tends to 0, tan x upon x, that is equals to 1. Limit x tends to 0, sin of kx upon x, that is equals to k. Limit x tends to 0, tan of kx upon x is equals to k. Limit x tends to 0, x into sin of 1 upon x, that is equals to 0. Limit x tends to 0, 1 minus cos of px upon x square, that is equals to p square upon 2. Limit x tends to 0, cos of mx minus cos of nx upon x square, that is equals to m square, n square minus n square upon 2. Limit x tends to 0, a raised to x minus 1 upon x is equals to log a for every a greater than 0. Limit x tends to 0, 1 plus x bracket raised to 1 upon x is equals to e. Limit x tends to 0, log of 1 plus x upon x is equals to 1. Limit x tends to a, x raised to n minus a raised to n upon x minus a is equals to n into a raised to n minus 1 for a is positive. Limit x tends to 0, e raised to x minus 1 upon x, and that is equals to 1. Limit x tends to 0, x tends to infinity 1 upon x, that is equals to 0. Now miscellaneous exercise. Miscellaneous exercise 7, the first problem. Select the correct answer from the given alternative. Limit x tends to 2, x raised to 4 minus 16 upon x square minus 5x plus 6 is equals to 23, 32 minus 32 minus 16. Limit x tends to 2, x raised to 4 minus 16, x square minus 5x plus 6. Limit x tends to 2, x raised to 4 minus 2 raised to 4. The factors are x minus 2 into x minus 3. And now the factors of x raised to 4 minus 2 raised to 4 can be written as x square minus 2 square into x square plus 2 square. Again, x square minus 2 square can be written as in first bracket x minus 2 into second bracket x plus 2 upon x minus 2 into x minus 3. Now x minus 2 get cancelled. See this formula. Again you can write it's like this. X minus 2 get cancelled. And now replace x by 2. That x is replaced by 2 plus 2, 2 square plus 4, 2 minus 3, This is 4, 8, minus 1, which is the minus 32. And therefore, the answer is minus 32. Therefore, the option C is the correct one. Now, see this again. And this also. These are the formulas. This is the example that we will see now here. And repeat again. Factors. The cancellation factor is x minus 2. Now replace x by 2 and the answer is minus 32. Therefore, the C option is the correct one. Next is second. Limit x tends to minus 2, x raised to 7 plus 128 upon x cube plus 8. Therefore, now it can be written limit x tends to minus 2, x raised to 7 plus 2 raised to 7 upon x cube plus 2 cube. Now this can be written as like this, x tends to minus 2. Now it can be written as x raised to 7 minus in bracket minus 2 raised to bracket raised to 7. If we simplify this, then you will get minus and minus will become plus and then you will get like this. And therefore, that is the, again, denominator is, that is x raised to 3. And again it can be written as divide n and d by x plus 2. And that x plus 2 can be written as like this, limit x tends to minus 2. Therefore, we can write like this by using the formula 7 into 2 raised to 7 minus 1 upon 3 into 2 raised to 3 minus 1. Now this is 7 by 3, 2 raised to 6 upon 2 raised to 2. Therefore, you will get 7 by 3 into 2 raised to 4. That is 7 into 16 upon 3. That is L is equals to 112 upon 3. See this again. That is limit x tends to minus 2, x raised to 7 plus 128 upon x raised to 3 plus 8. See this option. That is limit x tends to minus 2, x raised to 7 plus 2 raised to 7, x raised to 3 plus 2 raised to 3. Now this can be written as limit x tends to minus 2, x raised to 7 minus in bracket minus 2 raised to 7. Now divide n and d by x plus 2. Then it can be written as minus in bracket minus 2. Therefore, apply the formula. That is a limit x tends to a, x raised to n minus a raised to n upon x minus a. That is n into a raised to n minus 1. This is the formula to the numerator and the denominator. And then you will get the answer. That L is equals to 112 upon 3. And hence, option B is the correct one. Now the next is example number 3. Limit x tends to 3, 1 upon x square minus 11x plus 24 plus 1 upon x square minus x minus 6. Now as limit x tends to 3, therefore the cancellation factor is x minus 3. Now we'll simplify this. Answer is minus 2 upon 27, 2 upon 25 Minus 2 upon 25, 2 upon 25, 7 upon 25, minus 7 upon 25. Now simplify here, factorize. See, these are the factors. 1 upon x minus 3 into x minus 8 plus 1 upon x minus 3 into x plus 2. Now it is a common here, 1 upon x minus 3 is a common, and that is the limit x tends to 3. 1 upon x minus 8 plus 1 upon x plus 2 into 1 upon x minus 3. Now make the cross multiplication, limit x tends to 3, x plus 2 plus x minus 8 upon x minus 8 into x plus 2 into 1 upon x minus 2, x minus 3. Now simplification, limit x tends to 3, 2x minus 6 upon x minus 8 into x plus 2 into 1 upon x minus 3. Now x plus x is 2x plus 2 minus 8 minus 6. Take 2 as common, then in bracket you will get x minus 3. Now this x minus 3 and x minus 3 will cancel, and then replace x by 3. See this again, x tends to 3. Now this x minus 3 and x minus 3 get cancelled. Then you will get 2 upon x minus 8 into x plus 2. If we replace x by 3, that is a 3 minus 8 is minus, that is equals to minus 6. I think that here is a 3 minus 8. I will change it. That is a 3 minus 8, which is a minus 5. 2 upon 5, that is a 2 plus 3 is 5. And overall, the answer is minus 2 upon 25. And hence the option A is the correct one. Now again see this. Limit x tends to 3, 1 upon x square minus 11x plus 24 plus 1 upon x square minus x minus 6. Now factorize this. What are the factors? X square minus 11x plus 24. The factors are x minus 3, x minus 8. X square minus x minus 6. The factors are 1 upon x minus 3 into x plus 2. Therefore, take 1 upon x minus 3 as a common and make this cross multiplication, x plus 2 plus x minus 8 upon x minus 8 into x plus 2 into 1 upon x minus 2. And if we simplify this, limit x tends to 3, 2x minus 6 into x minus 8 into x plus 2 into 1 upon x minus 3. Take 2 as a common, then you will get x minus 3 upon x minus 8 into x plus 2. X minus 3 get cancelled, and then take the limit as x tends to 3, replace x by 3. Therefore you will get, that is a 3 minus 5, 3 minus 8, which is the minus 5, and 3 plus 2, that is a 5, that is equals to minus 2 upon 25, and hence the option A is the correct one, which is the minus 2 upon 25. Fourth one, limit x tends to 5 in root of x plus 4 minus 3 upon in root of 3x minus 11 minus 2. That is minus 2 upon 9, 2 upon 7, 5 upon 7, 2 upon 9. Limit x tends to 5 now here we can write it in root of 3x minus 11 minus 2. Now rationalize the denominator and the numerator, both rationalization. Now see this here, in root of x plus 4 minus 3 Now multiply the conjugate of this, which is the in root of x plus 4 plus 3 upon in root of x plus 4 plus 3 into in root of 3x minus 11 plus 2 upon in root of 3x minus 11 plus 2. Now what is the multiplication of this? The multiplication of this is x plus 4 minus 9. And what is the multiplication of this first and this last one? That is a 3x minus 11 minus 4. Now see this here. Limit x tends to 3. X plus 4 minus 9 into in root of 3x minus 11 plus 2. The denominator is also limit x tends to 5. Now see this here. X plus 4 minus 9. X plus 4 minus 9 means what? After simplification you will get x minus 5. In root of 3x minus 11 plus 2. And what about this? That the 3x minus 15. Take 3 as common. Then x minus 5 get cancelled. Replace x by 5. X minus 5 get cancelled. And then replace x by 5. Then you will get 1 upon 3 into in root of 4 plus 2 upon in root of 9 plus 3 that is here is a 2 plus 2, this is a 2 plus 2 and this is 3 plus 3, this is a 4 and 6, that is a 4 upon 3 into 6 and that is equals to 2 upon 9. Now the limit x tends to 5 in root of x plus 4 minus 3 upon in root of 3x minus 11 minus 2. Substitute the values, rationalize the denominator as well as the numerator. Therefore, multiply the conjugate of in root of x plus 4 minus 3, which is plus here. And for the denominator in root of 3x minus 11 minus 2, multiplied it with plus in root of 3x minus 11 plus 2. And their simplification. Now this is the radical sign, get cancelled. X plus 4 minus 9 into in root of 3x minus 11 plus 2 upon, again the radical sign get cancelled, 3x minus 11 minus 4. Now take, that is simplify this, that is x minus 5 and 3x minus 11, that is a 3 as common, x minus 5 get, x minus 5 get cancelled and replace x by 5, that is a 15 minus 11 4, root of 4 plus 2, root of 9 plus 3, that is 1 upon 3 into 2 plus 2 upon 3 plus 3, that is 1 by 3, 4 upon 6, that is a 2 upon 9. Hence option D is a correct one. Now next. Now the problem number 5. Limit x tends to pi by 3, tan square x minus 3 upon sec square x minus 8. A is 1, B is 1 upon 2, C is 1 upon 3, D is 1 upon 4. Now the limit x tends to pi by 3. Now this tan square x is replaced by sec square x minus 1 and it's a minus 3 upon sec square x minus 8 or 2 raised to 3. Now here is the limit x tends to pi by 3, sec square x minus 2 square and sec square x minus 2 cube. Split up this. Therefore, you will get sec x minus 2 get cancelled. And take the limit, that is a replace x by pi by 3. Then you will get limit x tends to pi by 3, sec x plus 2 sec square x plus 2 sec x plus 4, that is sec of pi by 3 plus 2, sec square of pi by 3 plus 2 times sec of pi by 3 plus 4. Therefore 2 plus 2, 2 square plus 2 into 2 plus 4, and simplify this, that is a 4 upon 12, and that is equals to 1 upon 3, and hence the option C is the correct one. Now limit x tends to pi by 3, tan square x minus 3 upon sec square x minus 8. A is 1, B is 1 upon 2, C is 1 upon 3, D is 1 upon 4. That is limit L is equals to x tends to pi by 3 sec square x. That is a tan square x can be written as sec square x minus 1, and this minus 3. Now what about here? Sec square x minus 8. Sec cube x, sorry, it's written as sec cube x. By mistake I had written sec square x, but it is a sec cube x. I will change it here. That is a sec cube x here must be. By mistake I had written sec. I can change it. This is the sec cube, and therefore it is written as, by using the formula a cube minus b cube, in first bracket sec x minus 2, second bracket sec square x plus 2 into sec x plus 4, sec x minus 2, let's get cancelled, limit x tends to pi by 3, substitute the value of sec of pi by 3, that is equals to 2, therefore sec of pi by 3 plus 2, sec square pi by 3 plus 2 into sec of pi by 3 plus 4, and after substitution you will get 4 upon 4 plus 4 plus 4, that is 4 upon 12, that is equals to 1 upon 3. Now next, that is option C is the correct one. Now the problem number 6. Limit x tends to 0, 5 sin x minus x cos x upon 2 tan x minus 3x square. A is 0, B is 1, C is 2, and D is 3. Now the limit x tends to 0. Now in this case, see this problem. To solve this problem, see this here. Divide numerator and denominator by x. If you take x, then you will, this sin x will get x. X cos x upon x, that is x's get cancelled. And 2 tan of x upon x, that is the tan x upon x. Minus 3 x square upon x, that x's get cancelled. Now see this here. Divide n and d by x. After doing the number of the time practice, then you can solve this. That is a 5 sin x minus x cos x upon x, 2 tan x minus 3x square upon x. Therefore 5 sin x upon x minus x cos x upon x. Next is 2 tan x upon x minus 3x square upon x. That is limit x tends to 0, 5 sin x upon x minus cos x upon tan of x and 3x. Therefore, as limit x tends to 0, sin of x upon x is 1, that is a 5 into 1, 5. And limit x tends to 0, cos of 0 is 1. And limit x tends to 0, tan x upon x, that is 1. Now, see this here. 5 into 1 minus 1. 2 into 1 minus 0, 5 minus 1 and 2. Therefore, you will get 4 upon 2, and that is equals to 2. L is 2. Therefore, option C is the correct one. Now again see here. That is a limit x tends to 0, 5 sin x minus x cos x upon 2 tan x minus 3x square. 0, 1, 2, 3, these are the options. We see this, the requirement of the divide n and d by x. Therefore, divide n and d by x, we are dividing here. Separate it, 5 sin x minus x cos x upon x, and it is written as limit x tends to 0. 5 sin x upon x minus x cos x upon x upon 2 tan x upon x minus 3 x square upon x. That is a limit x tends to 0, 5 sin x upon x minus cos x upon 2 tan x upon x minus 3x, and you will get limit x tends to 0, sin x upon x, that is equals to 1, which is 5 into 1 minus 1 and 2 into 1 minus, that is a 0, and 5 minus 1, 2 minus 0, 4 upon 2, that is equals to 2. Therefore, the option C is a correct one. Now the next is limit x tends to pi by 2, 3 cos x plus cos of 3x. Now here is a again by mistake. That is, I think that here is a 2x minus pi bracket cube. I will change it. Now what is the cos of 3 theta? Cos of 3 theta is a 4 cos cube theta minus 3 cos theta. And by using this formula, that is nothing but that is a cos of 3 theta plus 3 cos theta, 4 cos cube theta. Simplify this. Therefore, 4 cos cube theta is equals to cos of 3 theta plus 3 cos theta. That is equals to cos cube theta is equals to 1 by 4 cos of 3 theta plus 3 cos theta. This is the formula that you have to remember. Cos cube theta means what? 1 by 4 cos of 3 theta plus 3 cos theta. Now the limit x tends to pi by 2, 4 cos cube x upon 2x minus pi bracket cube. Now here I have to replace, that is x. Now put x is equals to pi by 2 plus h, as x tends to pi by 2, h tends to 0. This is the substitution. That if we replace x by pi by 2, then pi by 2 is equals to pi by 2 plus h. The value of h is 0. Therefore, we say that h tends to 0. That is the limit. L is equals to limit h tends to 0. 4 cos cube in bracket pi by 2 plus h and to the denominator, substitute the value of x. That is the 2 in bracket pi by 2 plus h minus pi bracket cube, limit h tends to 0, 4 cos of pi by 2 plus h. Now cos of pi by 2 plus h, whenever there is angle pi by 2 plus theta, the function changes. Now cos of pi by 2 plus h goes in second quadrant. In second quadrant, cos is negative. Therefore, overall minus 4 sin cube h will be there. Now see this here. And simplification of this. What is simplification of this? That is a 2 into pi by 2. That is a plus pi and minus pi get cancelled. And 2 into h. That is a 2h bracket cube. That is equals to 8h cube. Now see this again. Cos of pi by 2 plus h is minus sin theta. Therefore, limit is, that is a 2h bracket cube means what? 2 raised to 3, which is 8, minus 4 upon 8, limit h tends to 0, sin cube h upon h cube. And the value of that answer is 1 cube. That is a minus 1 upon 2 into 1 cube, as limit h tends to 0, sin cube h upon h cube. That is 1 raised to 3. And 1 raised to 3 is 1. Therefore, overall answer is minus 1 upon 2. C is minus 1 upon 2. Hence, option C is a correct one. Now, again see this here. That is a 3 cos x plus cos of 3x, 2 pi, 2x minus pi. Now, here I can change it. This is a 2x minus pi Now what is the formula? Cos of 3 theta is equals to 4 cos cube theta minus 3 cos theta. And again, we'll write in this form. That is the cos of 3 theta plus 3 cos theta is equals to 4 cos cube theta. Therefore, 4 cos cube theta is equals to cos of 3 theta plus 3 cos theta. Cos cube theta is equals to 1 by 4 cos of 3 theta plus 3 cos theta. This is the value. And therefore, that is nothing but the 4 cos cube x upon 2x minus 5 bracket raised to 3. Now here is important substitution. Put x is equals to pi by 2 plus h, as x tends to pi by 2, h tends to 0. Therefore, replace x by pi by 2 plus h. And the value of 2x minus 5, that is a 2 in bracket pi by 2 plus h minus 5 bracket cube. And that's why you will get cos cube pi by 2 plus h, which is minus sin h. But it has a cube sign, that is a minus into minus into minus. Overall, it will become minus 4 sin cube h upon. This is the pi, plus pi minus pi get cancelled. That is a 2h bracket cube. 2h bracket cube means what? 2 raised to 3, which is 8 here. H cube. This is a minus 4. Therefore, minus 4 upon 8 into limit h tends to 0. Sin cube h upon h cube. As limit h tends to 0, the value of this limit is 1 raised to 3. And that is equals to minus 1 upon 2. And hence option C, which is minus 1 upon 2, is a correct one. Now the problem number 8. Limit x tends to 0. 15 raised to x minus 3 raised to x minus 5 raised to x plus 1 upon sin square x. Now see this here, important. We have solved this type of the problems also. 15 raised to x minus 3 raised to x minus 5 raised to x plus 1. Now this 15 can be written as 5 into 3 bracket raised to x. And then solve. Divide the numerator and denominator by x square, and then you will get the answer. Now see this here. The option A is log of 15. Option B is log of 3 plus log of 5. C is log of 3 into log of 5. And D is 3 log of 5. Limit x tends to 0. Now 15 can be written as 5 into 3 bracket raised to x minus 3 raised to x minus 5 raised to x plus 1 sin square x. Limit x tends to 0. 5 raised to x into 3 raised to x minus 3 raised to x minus 5 raised to x plus 1. Now take 3 raised to x common from these two. Then in bracket you will get 5 raised to x minus 1 and minus 1 in bracket 5 raised to x minus 1 upon sin square x. Divide n and d by x square. 5 raised to x minus 1 into 3 raised to x minus 1 upon sin square x. Divide n and d by x square. Therefore, limit x tends to 0. 5 raised to x minus 1 upon x into 3 raised to x minus 1 upon x upon sin square x upon x square. And now see this, as limit x tends to 0, the answer of this is log of 5 into log of 3 upon 1 square. And you will get log of 5 into log of 3. Direct answer, log of 5 into log of 3 upon 1 square, and this is the answer. Therefore, the option C is the correct one, log of 5 into log of 3. Now see this again here. 5 raised to x, limit x tends to 0, 15 raised to x minus 3 raised to x minus 5 raised to x plus 1 upon sin square x. Log of 15, log of 3 plus log of 5, log of 3 into log of 5 plus 3 times log of 5. Now again this 15 can be written as 5 into 3 bracket raised to x. Take the common. 5 raised to x into 3 raised to x minus 3 raised to x minus 5 raised to x plus 1 upon sin square x. And now as 3 raised to x is common, 5 raised to x minus 1 minus 5 raised to x minus 1. 3 raised to x common. Then you will get 3 raised to x minus 1 in next bracket, and first bracket 5 raised to x minus 1. Now divide this numerator and denominator by x square. Split up this x, and answer from the first bracket is log of 5 and the second bracket is a log of 3. Log of 5 into log of 3 upon 1 square. Log of 3 into log of 5. That is a C, log of 3 into log of 5. Limit x tends to 0. 3 plus 5x upon 3 minus 4x whole bracket raised to 1 upon x. The answers are e raised to 3, e raised to 6, e raised to 9, e raised to minus 3. Limit x tends to 0. 3 plus 5x upon 3. Because we will require the of the form, that is 1 plus x bracket raised to 1 upon x. Therefore here we will divide numerator and the denominator by 3. 3 plus 5x upon 3. 3 minus 4x upon 3. Therefore as limit x tends to 0, 1 plus 5 upon 3 into x and 1 minus 4 upon 3 into x. And 1 plus 5x upon 3 whole bracket raised to 1 upon x, 1 minus, see this here, whole bracket raised to 1 upon x. Now here is 1 plus 5x upon 3. Now the reciprocal of this is 3 upon 5x. And to adjust here, we are again the bracket raised to 5 upon 3. Now what is here? 1 plus 5x upon 3. We require a reciprocal of 5x upon 3, which is 3 upon 5x. We have already 1 upon x here. But what is the new term here? 3 by 5. We adjust here 5 by 3. Same in case of the denominator, limit x tends to 0. 1 minus 4x upon 3 will require minus 3 upon 4x. And it is adjusted by minus 4 upon 3. The value of this limit is e raised to 5 by 3 and e raised to minus 4 upon 3. Add this, e raised to 5 by 3 plus 4 by 3. That is a 9 by 3, which is e raised to 3. By using this formula, as limit x tends to 0, 1 plus x bracket raised to 1 upon x, that is the value is e raised to 3. Now see this again. Now the 10th question. Limit x tends to 0, log of 5 plus x minus log of 5 minus x upon sin x. Now this is also important and interesting problem. The option A is a 3 by 2, B is minus 5 by 2, C is minus 1 upon 2 and D is 2 upon 5. Now the limit x tends to 0. Now see this. I am using the applications of, that is using the formula for the log, that is the log of m minus log of n. Then you will get log of m upon n. Then divide the numerator and the denominator by 5. The denominator is a sin x. Limit x tends to 0. The log of 1 plus x upon 5, 1 minus x upon 5. And the denominator is a sin x. And here is a log of 1 plus x upon 5 minus log of 1 minus x upon 5 divided by x sin x upon x. Limit x tends to 0. Log of 1 plus x upon 5 upon x upon 5. That is, here we will require. That is log of 1 plus x upon 5 upon x. But what is here? Our standard formula is log of limit x tends to 0. Log of 1 plus x upon x. Now here is x upon 5. Therefore, we write here x upon 5 into 1 upon 5. That is 5 is adjusted here minus log of, that is, see this here, not here minus sign, adjusted minus sign is here. That is a plus log of 1 minus x upon 5 minus x upon 5. Now I adjusted minus sign is here and I had written here is a plus sign into 1 upon 5. See this here, 1 upon 5 sin x upon x. Now see this here, as limit x tends to 0, the value of this limit is 1. 1 into 1 upon 5 plus 1 into 1 upon 5. That is a 2 upon 5 upon 1. Therefore, you will get 1 by 5 is common. Which is 2 upon 5. D is 2 upon 5. Log of 1 plus x upon x as limit x tends to 0. The limit is 1. Now the next 11. Limit x tends to pi by. Before that we'll see. Now see this limit x tends to 0. Log of 5 plus x minus log of 5 minus x upon sin x. A is 3 by 2. B is minus 5 by 2. C is minus 1 upon 2. And D is 2 by 5. L limit x tends to 0. Log of 5 plus x upon 5 minus x upon sin x. Limit x tends to 0. Log of divide n and d by 5. Then you will get log of 1 plus x upon 5 upon 1 minus x upon 5 upon sin x. Limit x tends to 0. Log of 1 plus x upon 5 minus log of 1 minus x upon 5 upon x sin x upon x. And adjust here 1 by 5. Split up it. Minus sign I had taken here because log of 1 minus x upon 5. Therefore, we require minus x upon 5 into 1 upon 5. Therefore, here is a take 1 by 5 as common. Log of 1 plus x upon 5 upon x upon 5 plus log of 1 minus x upon 5 minus x upon 5. Sin x upon x, that is 1 by 5 in bracket 1 plus 1 upon 1, which is the 2 by 5. Limit x tends to 0. Log of 1 plus x upon x, that is 1, and that is a 2 by 5. Now the next is limit x tends to pi by 2. 3 raised to cos x minus 1 upon pi by 2 minus x. And the options are A is 1. That is a log of 3. 3 raised to pi by 2. 3 log of 3. This is a very interesting problem. Limit x tends to pi by 2. 3 raised to cos x minus 1 upon pi by 2 minus x. Put x is equals to pi by 2 plus x, as x tends to pi by 2, x tends to 0. Therefore, limit x tends to 0. 3 raised to cos in bracket pi by 2 plus h minus 1 upon, that is pi by 2 minus x, that is nothing but the minus h, and the limit x tends to 0. Now what is the cos of pi by 2 plus h? It goes in second quadrant, which is the minus sin h, that is 3 raised to minus sin h minus 1 minus h, that is the limit h tends to 0. 3 raised to minus sin h minus 1 upon minus sin h, that is whatever the exponent here that we required here, that is a 3 raised to minus sin h upon minus sin h Minus sign h is here adjusted where, and upon this minus h. Therefore, this is the log of 3, log of 1. Value of this limit, then limit minus minus will become plus, and therefore you will get limit x tends to 0, a raised to x minus 1 upon x, that is equals to log of a as x tends to 0, sin h tends to 0. These are the dialogues for you have to write for every problem, whatever that there are the changes. Now L is equals to log of 3. This is a B option is correct one. Again we will see here 11. Limit x tends to pi by 2, 3 raised to cos x minus 1, pi by 2 minus x. A is 1, log of 3, 3 raised to pi by 2, 3 log of 3. And see this again, 3 raised to cos x minus 1, pi by 2 minus x. Put x is equals to pi by 2 plus h as x tends to pi by 2, h tends to 0, h tends to 0. 3 raised to cos of pi by 2 plus h minus 1 minus h. Limit x h tends to 0, 3 raised to minus h minus 1 upon minus h. L is equals to limit h tends to 0, 3 raised to minus h minus 1 upon minus sin h into minus h upon h. Therefore, you will get log of 3 into 1, and L is equals to a log of 3, and hence option B is a correct one. Now the 12, limit x tends to 0, x log of 1 plus 3x upon 3x minus 1 bracket square. The answer is 1 upon e raised to 9. B is 1 upon e raised to 3, 1 upon 9, 1 upon 3. Limit x tends to 0, x log of 1 plus 3x upon x square, e raised to 3x minus 1 upon x square. Therefore, limit x tends to 0, log of 1 plus 3x upon 3x into 3, e raised to 3x is the bracket square. Now we have to adjust here, that is a 9. It's a bracket square, therefore this is a 9 multiplied by 9 here. That is log of 1 plus 3x upon 3x is 1. 1 into 3, that is a 3. And what about here 1? 1 square into 9, that is a 9. That is equals to 1 upon 3. Therefore, limit L is equals to 1 upon 3. And hence the option is a correct one. If we see this problem, that is the limit x tends to 0, x log of 1 plus 3x upon e raised to 3x minus 1 bracket square. Now divide n and divide x square, then you will get the answer. What will happen here? This exercise get cancelled. That is a log of 1 plus 3x upon x. But here we require here we have the 3x, therefore it must be the 3x. Therefore we are adjusting here 3 to the numerator and the denominator. Therefore log of 1 plus 3x upon 3x into 3. What about the denominator? The denominator e raised to 3x minus 1 bracket square upon x square, that is e raised to 3x minus 1 upon 3x bracket square into 9. Now here is a 3 square, means what? 9. Therefore we are dividing by 9, at the same time multiplied by 9. Therefore value of this limit is 1, and this is a 1 square. 1 into 3, 1 square into, that is equals to 1 upon 3. Therefore D is equals to 1 upon 3, that is a correct one. Now the next is 13. Limit x tends to 0, 3 raised to sin x minus 1 bracket cube upon 3 raised to x minus 1 into tan of x into log of 1 plus x. Now in this case here is a cube here. We will record here x, x and x. Therefore overall divide n and divide x cube. Now see this. The options are A is 3 log of 3, B is 2 log of 3, C is log of 3 bracket square, and D is I will see that the last option. I will make the correction in that. Now the limit here, that is a 3 raised to sin x minus 1 bracket cube upon x cube, 3 raised to x minus 1 upon x into tan of x upon x into log of 1 plus x upon x. That is, divide n and d by x cube and split up this x, so x, x and x. Therefore, 3 raised to sin x minus 1 upon sin x bracket cube into sin of x upon x cube. Now here is a 3 raised to x. Therefore, to the denominator we will require sin x. But it will become sin cube x. Therefore, we are adjusting here to the numerator and the denominator for this sin cube x. And divided by this x square. It is useful here. And to the denominator 3 raised to x minus 1 upon x tan of x upon x and log of 1 plus x upon x. Now the value of this is log of 3 bracket cube 1 cube log of 3 1 1. See this here. Bracket. This is log of 3 bracket square 1 cube log of 3 into 1 into 1 log of 3 bracket cube log of 3. Then you will get log of 3 bracket square. Now see this again here. 13. Limit x tends to 0. 3 raised to sin x minus 1 bracket cube upon 3 raised to x minus 1 into tan of x into log of 1 plus x. Now divide n and d by x cube. Split up it. Adjustment 3 raised to x minus 1 upon sin x bracket cube into sin cube x upon x cube. 3 raised to x minus 1 upon x tan x upon x log of 1 plus x upon x. Take their limit log of 3 bracket square into 1 cube log of 3 into 1 into log of 3 bracket cube log of 3. That's you will get log of 2 and that's why log of 3 bracket square. Now limit x tends to 3. 5 raised to x minus 1 4 raised to x 5 raised to x minus 3 4 raised to x minus 3 upon sin of x minus 3. Now one common relation is here x minus 3 x minus 3 x minus 3. And limit is also tends to x tends to 3. Therefore, put x is equals to 3 plus h and solve that example. You will get the answer. The option A is a log of 5 minus 4. B is a log of 5 by 4. Log of 5 upon log of 4. Log of 5 upon 4. Limit x tends to 3. 5 raised to x minus 3 minus 4 raised to x minus 3 upon sin of x minus 3. Put x is equals to 3 plus h as x tends to 3, h tends to 0. Limit h tends to 0. 5 raised to h minus 4 raised to h upon sin h. Again divide numerator and denominator by h, then you will get the answer. That is limit h tends to 0. 5 raised to h minus 4 raised to h upon h sin h upon h. And now here adjustment of plus 1 and minus 1 is there. That is by using also the one more standard result, that is the limit x tends to 0, a raised to x minus b raised to x upon x. That is nothing but the log of a upon b. And in the same way, that is a log of 5 by 4. Therefore, option B is the correct one, log of 5 by 4. 15. Now, you can say that limit x tends to 3, 5 raised to x minus 3 minus 4 raised to x minus 3 upon sin of x minus 3. These are the options. Now, solve this limit. Put x is equals to 3 plus h. As x tends to 3, h tends to 0. That is a limit h tends to 0. 5 raised to h minus 4 raised to h upon sin h. Therefore, divide n and d by h. Limit h tends to 0. 5 raised to h minus 4 raised to h upon h. That is nothing but the log of 5 by 4 and sin h upon h. That is equals to 1. Therefore, L is equals to log of 5 by 4. Therefore, B is a log of 5 by 4. Now the next is limit x tends to infinity. 2x plus 3 bracket raised to 7. X minus 5 bracket raised to 3. 2x minus 5 bracket raised to 10. Now divide n and d by x raised to 10. These are the options. Divide n and d by, because the total power is 10. Limit x tends to infinity. 2x plus 3 bracket raised to 7. X minus 5 bracket raised to 3. 2x minus 5 bracket raised to 10. Divide n and d by x raised to 10. Limit x tends to infinity. 2x plus 3 bracket raised to 7 upon x raised to 7 into 2x minus 5 bracket raised to 3 upon x cube. 2x minus 5 bracket raised to 10 upon x raised to 10. Therefore, limit x tends to infinity. 2x plus 3 bracket raised to 7. X minus 5 upon x bracket raised to 3. 2x minus 5 upon x bracket raised to 10. Simplify this. That is the limit x tends to infinity. 2 plus 3 upon x bracket raised to 7. 1 minus 5 upon x bracket raised to 3. And if you split it, then you will get 2 minus x upon 5 raised to 10. As x tends to infinity, 3 upon x, 5 upon x, 5 upon x, these all tends to 0, then you will get 2 raised to 7, 1 raised to 3, 2 raised to 10. Now see this here. 2 plus 0, 1 minus 8, 1 minus 0 bracket raised to 3, and that is equals to 1 over 8. The option is the correct one. Now again, now see this again, limit x tends to infinity, 2x plus 3 bracket raised to 7, x minus 5 bracket raised to 3, 2x minus 5 bracket raised to 10. These are the options. Limit x tends to infinity, 2x plus 3 bracket raised to 7, x minus 5 bracket raised to 3, 2x minus 5 bracket raised to 10. Divide n and divide x raised to 10. Split up it, x raised to 7 here, x raised to 3 here, upon x raised to 10. Then in the compact in same bracket, that is a 2x plus 3 upon x and whole bracket raised to 7. X minus 5 upon x whole bracket raised to 3. This way. 2x minus 5 upon x whole bracket raised to 10. Split up it. 2x upon x, that you will get 2 plus 3 upon x, 1 minus 5 upon x, and next is a 2 minus 5 upon x. As limit x tends to infinity, the second term is becoming 0. 2 raised to 7, 1 raised to 3, 2 raised to 10, and overall you will get 1 upon 8. That is option B is the correct one. Now the question number 2. Evaluate the following. First is L, limit x tends to 0. 1 minus x bracket raised to 5 minus 1 upon 1 minus x bracket raised to 3 minus 1. Put 1 minus x is equals to h. Then as x tends to 0, h tends to 1. If we substitute x is equals to 0 here, then h is equals to 1. Therefore, we say that h tends to 1. Therefore, L, limit x tends to, h tends to, x tends to 0, 1 minus x bracket raised to 5 minus 1 upon 1 minus x bracket raised to 3 minus 1. Limit h tends to 0, h raised to 5, h raised to 5 minus 1 upon h cube minus 1. Now divide n and d by h minus 1. Therefore, you will get limit h tends to 1, h raised to 5 minus 1 raised to 5 upon h minus h cube minus 1 upon therefore, you will get 5 into 1 raised to 5 minus 1 upon 3 into 1 raised to 3 minus 1. Therefore, the answer is 5 upon 3. That is the limit x tends to x raised to n minus a raised to n upon x minus a is equals to n into a raised to n minus 1. L is equals to 5 upon 3. Second, limit x tends to 0, 1 minus x bracket is to 5 minus 1 upon 1 minus x bracket is to 3 minus 1. Put 1 minus x is equals to h. Then as x tends to 0, h tends to 1. L, limit x tends to 0. 1 minus x bracket is to 5 minus 1 upon 1 minus x bracket is to 3 minus 1. Limit h tends to 1. H raised to 5 minus 1 upon h cube minus 1. Divide n and divide h minus 1. Therefore, limit h tends to 1. H raised to 5 minus 1 raised to 5 upon h minus 1. H raised to 3 minus 1 raised to 3 upon h minus 1. That is a 5 into 1 raised to 5 minus 1 upon 3 into 1 raised to 3 minus 1 by using this formula. Therefore, you will get 5 upon 3. Therefore, L is equals to 5 upon 3. Limit x tends to 0. This is the in square bracket x, that is nothing but the greatest integer function. Now we know that is a greatest integer function. X is equals to 0 if it lies between 0 to 1. And its a greatest integer function is 0. And next is minus 1 lies between, that is x lies between minus 1 to 0. Then it is a minus 1. Therefore, in this case, limit x tends to 0 plus of x. That is equals to 0. That is the right hand side limit. And limit that is equals to minus 1. Hence, both are not equal and therefore limit does not exist. Does not exist. Now see the second here. That is limit x tends to 0 in square bracket x. That is the greatest integer function. We know that greatest integer function x is equals to 0 if x lies between 0 and 1 is equals to minus 1 if it lies between minus 1 to 0. And therefore, for the right hand side limit, limit x tends to 0 plus, that is equals to 0, and limit x tends to left hand side limit, that is equals to minus 1, which is minus 1, and hence the limits are not equal, therefore the limit does not exist. Now the next is problem number 3. If f of x is equals to pi r square, find limit h tends to 0 f of r plus h minus f of r upon h. This is also the first principle definition. It's simple one. F of r is there, not f of x. F of r is equals to pi r square. F of r is equals to pi r square f of r plus h. Pi in bracket r plus h bracket square. Now r plus h bracket square means what? R square plus 2 rh plus h square. That is a pi r square plus 2 pi rh plus pi h square. That is the limit h tends to 0 f of x plus h minus, sorry, here must be r here, f of r plus h minus f of r upon h limit h tends to 0. F of r plus h, the value of f of r plus h is pi r square plus 2 pi rh plus pi h square. After substituting upon h, limit h tends to 0 to pi r h plus pi h square upon h. Limit h tends to 0 pi h upon 2r plus h upon h. This get cancelled, and then you will get pi in bracket 2r plus h, that is a 2 pi r. And this is nothing but the derivative of pi r square, that is a 2 f dash of r is equals to 2 pi r. Now see this again here. F of x is equals to pi r square. Limit h tends to 0, f of r plus h minus f of r upon h. F of x is equals to f of r is equals to pi r square. F of r plus h is equals to pi in bracket r plus h. Expand this, and next is now here must be the r here. That is f of r plus h minus f of r upon h. Substitute the value, simplify, get cancelled. Take pi h common, then in bracket you will get rh, r to r plus h upon h. That is a pi in bracket 2r plus h, that is a 2 pi r. Therefore, the f dash of r is equals to 2 pi r. If f of r is equals to pi r square, f dash of r is equals to 2 pi r. Now, next. Now the fourth one. If f of r is a pi r square, then its derivative is a 2 pi r. Differentiation with respect to r. Next is limit x tends to 0, x upon mod of x upon x square. That is, we know that the mod of x is equals to x if x is positive. That is, x is greater than 0 and equals to minus x if x is less than 0. Therefore, limit x tends to 0. That is the right hand side limit. If we take that is a 0 plus, means what? Mod of x is equals to x. That is x upon mod of x plus x square. The value of this mod of x is stated as x. Now see this here. That is the limit x tends to 0, x upon x plus x square. This x get cancelled. If you take, then you will get that is equals to 1. And now for the left hand side limit, therefore limit x tends to 0 minus x plus x square. Take x as a common, then you are getting the minus 1 as a limit here. See this here. And both are not equal, therefore the limit of that function does not exist. Left limit is not equals to the right limit, therefore the limit does not exist. Limit exist असण्यासाठी दोन्ही equal पाहिजे. Does not exist. Now, limit x tends to 0, x upon mod of x plus x square. We know that mod of x is equals to x. If x is positive, is equals to minus x. If x is negative, we have the right hand side limit. Limit x tends to 0 plus x upon mod of x plus x square. Substitute the value of mod of x is x. X upon x plus x square. Take x as common. X get cancelled. As limit x tends to 0, x is replaced by 0. 1 upon 1 plus 0, that is equals to 1. Limit x tends to 0 minus, that is left hand side limit, x upon mod of x plus x square. With it, the value of that is minus x. Minus x plus x square, take x as a common, x get cancelled. 1 upon x minus 1, that is equals to minus 1. And therefore both are not equal, and hence the limit does not exist. Fifth, find the limit of the function if it exists at x is equals to 1. If f of x is equals to 7 minus 4x for x is less than 1, x square plus 2 for x is greater than or equal to 1. And here we will take the left hand side limit and right hand side limit. For the left hand side limit, x is less than 1. The the function breaks at x is equals to 1. Therefore, limit x tends to 1 minus means what? Left hand side limit. Then as x is less than 1, therefore we take the function 7 minus 4x. And x is greater than 1, that is the right hand side limit. Then we take the function x square plus 2. Therefore, see this here, left hand 7 minus 4x, that is 7 minus 4, that is x is replaced by 4, x is replaced by 1, that is 7 minus 4 into 1, that is 7 minus 4, that is equals to 3. Limit x tends to, that is equals to 3. This is 1. Limit x tends to 1 plus, that is the right hand side limit. And for that, limit x tends to 1 plus, means what? X square plus 2. Replace x by 1, that is 1 plus 2, that is equals to 3. Now here both are equal. Left hand side limit is equals to the right hand side limit, and hence the limit of the function exists. Now see this again here. Number 5. F of x 7 minus 4x, x is less than 1. X square plus 2 for x is greater than or equal to 1. Left hand side limit. The value of the left hand side limit is 3. X is replaced by 1 here. 7 minus 4 is 3. Now next is the right hand side limit, x square plus 2. Right hand side, the function is here, x square plus 2. X is replaced by 1, 1 plus 2, 3. Now left limit is equals to the right limit, and hence the limit of the function exists, and that is equals to 3. Now see this here. The given function f of x lies between 7x and 3x square minus 6. For all x, determine the value of the limit as x tends to 3. Now it is given that 7x is less than or equal to f of x is less than or equal to 3x square minus 6 for all x. I will take the limit of this inequality. Limit x tends to 3, 7x less than or equal to x tends to 3 of f of x less than or equal to limit x tends to 3, 3x square minus 6. Now replace x by 3, then you will get 21. That is a 21 less than or equal to x is by 3. That is a 9. 9 into 3, 27 minus 6. And you will get, therefore f of limit x tends to 3, f of x is equals to 21. That is equals to 21. Now we'll see here again. 7x, f of x lies between 7x and 3x square minus 6. Take the limit as x tends to 3. Here is a 7x as x tends to 3 is a 21, and 3x square minus 6 is a 21. Therefore, as limit x tends to 3, f of x is equals to 21. Now the seventh problem. Limit x tends to 0, sec square x minus 1 upon, sec x square minus 1 upon x raised to 4. Now here is one important thing is that it's not the function square, it's a variable square. Sec x square minus 1 upon x raised to 4. Therefore, sec x square minus 1 upon x raised to 4. Now multiply n and d by sec x square plus 1 upon sec x square plus 1. Then you will get sec square x square minus 1 upon x raised to 4. Now see this here. A minus b into a plus b. Then you will get sec square in bracket x square minus 1 upon x raised to 4 in bracket sec x square plus 1. And that is nothing but the limit x tends to 0 tan square x square upon x raised to 4 into 1 upon x square plus 1. That is a tan of x square upon x square in whole bracket raised to 2. 1 upon x square plus 1. That is a 1 square. And limit of this is x tends to 0. Sec 0 is 1. 1 upon 1 plus 1. That is 1 upon 2 into 1. For all it is 1 upon 2. See this here. The limit is 1 upon 2. Again, you can see also here. Limit x tends to 0. Sec square x minus 1 upon x raised to 4. Multiplied n and d by sec of x square plus 1 upon sec of x square plus 1. Therefore, sec square in bracket x square minus 1. X raised to 4. Sec x square plus 1. Therefore, tan square in bracket x square upon x raised to 4. Now here is function square. Therefore, variable also square. Square of the variable required by. Here is x square and bracket raised to 4 into 1 upon sec x square plus 1. Now take the limit, you will get the answer. This is a 1 upon sec of 0 plus 1. 1 into 1 upon 1 plus 1, that is equals to 1 upon 2. Therefore, the limit is 1 upon 2. Now the problem number 8. Limit x tends to 0, e raised to x plus e raised to minus x minus 2 upon x tan x. Now here is e raised to x plus e raised to minus x minus 2. This can be converted into a plus a minus b bracket square in that form. Now see this here. E raised to x plus e raised to minus x minus 2, and that is equals to e raised to x plus 1 upon e raised to x and minus 2. And if you simplify that, then you will get e raised to x bracket square plus 1 minus 2 times e raised to x upon e raised to x. That is nothing but the e raised to x minus 1 bracket square upon e raised to x. Therefore, e raised to x plus e raised to minus x minus 2 is nothing but the e raised to x minus 1 bracket square upon e raised to x. Therefore, limit x tends to 0, e raised to x plus e raised to minus x minus 2 upon x tan x. That is the limit x tends to 0, e raised to x minus 1 bracket square upon x tan x into 1 upon e raised to x. Now divide n and d by x square. Now here we will require x square. X tan x upon x square, that x is it cancelled. Then you will get tan of x upon x, and that is 1. Now see this here. Divide n and d by x square. Limit x tends to 0, e raised to x minus 1 bracket square upon x square. X tan x upon x square into 1 upon e raised to x. Now the value of this limit is 1. 1 square is 1. Tan of x upon x is 1 as x tends to 0. And as x tends to 0, 1 upon e raised to 0. E raised to 0 is 1, which is 1 upon 1. That is 1 square is 1 upon 1 into 1. Overall, the answer is 1. Now see this again here. Limit x tends to e raised to x plus e raised to minus x minus 2 upon x tan x. Simplification. E raised to x. Here is a minus sign, therefore it becomes plus when we take it to the denominator. e raised to x plus 1 upon e raised to x minus 2. Now this is the perfect square. That e raised to x into e raised to x bracket square plus 1 minus 2 times e raised to x. That is e raised to x bracket square plus 1 minus 2 e raised to x whole divided by e raised to x. Now this is the perfect square. E raised to x minus 1 bracket square upon e raised to x. This is. Now the next, divide n and dy x square. Then you will get e raised to x minus 1 bracket square upon x square. X tan x upon x square into 1 upon e raised to x. Therefore, you will get e raised to x minus 1 bracket square upon x whole square. The value of this e raised to x minus 1 upon x is 1 square. Tan x upon x is 1. As x tends to 0, e raised to 0 is 1. Overall, L is equals to 1. Now the next is limit x tends to 0, x into 6 raised to x minus 3 raised to x upon cos of 6x minus cos of 4x. Now the limit x tends to 0, x into 6 raised to x minus 3 raised to x. Now apply the formula of the cos c minus cos d. That is nothing but the minus 2 sine of c plus d upon 2 into sine of c minus d upon 2. This is the formula. Cos c minus cos d is equals to minus 2 times sine of c plus d upon 2 into sine of c minus d upon 2. Therefore, limit x tends to 0. X into 6 raised to x minus 1 minus 3 raised to x plus 1 and to the denominator minus 2 sine of, what is here, 6x plus 4x, that is a 10x upon 2, which is 5x. 6x minus 4x, that is a 2x upon 2, which is sin x. Now divide numerator and denominator by x. Therefore, limit x tends to 0, 6 raised to x minus 1 upon x. Three raised to x minus 1. Right. Divide n and d by x square. Then this x get cancelled. Limit x tends to 0, 6 raised to x minus 1 minus 3 raised to x minus 1 upon x minus 2 sine of 5x upon 5x into sine of x upon x. We are adjusting here 5. The value of this limit is log of 6 minus log of 3 minus 2 into 5, that is a minus 1 upon 10, and here is sine of 5x upon 5x is 1 into 1. Therefore, minus 1 upon 10, limit x tends to 0, 6 raised to x minus 1 upon x minus 3 raised to x minus 1 upon x. Sine of 5x upon 5x into sin x upon x, that is minus 1 upon 10 log of 6 minus log of 3 into 1 upon 1 into 1, that is the minus 1 upon 10 log of 6 upon 3. Now see this here, minus 1 upon 10 log of 6 upon 3, that is the log of 2. Now see this again here. Divide n and d by x square. Apply the formula cos c minus cos d minus 2 times sine of c plus d upon 2 into sine of c minus d upon 2. Divide n and d by x square. That x get cancelled. minus 1 upon 10, limit x tends to 0, in bracket 6 raised to x minus 1 upon x minus 3 raised to x minus 1 upon x into 1 upon sine of 5x upon 5x into sine of x upon x. The minus 1 upon 10 into log of 6 minus log of 3 into 1 upon 1 into 1. That is the minus 1 upon 10 into log of 6 upon 3 minus 1 upon 10 log of 2. Therefore, L is equals to minus 1 upon 10 log of 2. Now the next example is example number 10. Limit x tends to 0. A raised to 3x minus a raised to 2x minus a raised to x plus 1 upon x tan x. Now the limit x tends to 0. A raised to 3x minus a raised to 2x minus a raised to x plus 1 upon x tan x. Take a raised to 2x common from these first two terms. Then you will get a raised to 2x in bracket a raised to x minus 1 and minus sign common from these two. That is the minus 1 in bracket a raised to x minus 1. X tan x. Limit x tends to 0. A raised to x minus 1 in second bracket a raised to 2x minus 1 upon x tan x. Now divide numerator for this term. It requires 1x and it is also x. Therefore divide n and d by x square. Therefore limit x tends to 0. A raised to x minus 1 upon x, a raised to 2x minus 1 upon x upon x tan x upon x tan x. Now here limit x tends to 0. A raised to x minus 1 upon x. A raised to 2x minus 1 upon 2x. Here is a raised to 2x. Therefore to the denominator, here we will require 2x. And 2 is adjusted here. Multiplied and divided by 2. And the whole divided by 1 x is get cancelled. You will get tan x upon x. Therefore, the first is log a. Second is a log of a into 2 upon 1. That is a 2 times the log of a bracket square. Therefore, the answer is 2 times log of a bracket square. Now see this again. Limit x tends to 0. A raised to 3x minus a raised to 2x minus a raised to x plus 1 upon x tan x. Take a raised to 2x as common. Then in bracket you will get a raised to x minus 1. Minus in bracket a raised to x minus 1 upon x tan x. Then take a raised to x minus 1 common. Then you will get a raised to 2x minus 1 upon x tan x. Divide numerator and the denominator by x square and you will get a raised to x minus 1 upon x into a raised to 2x minus 1 upon x upon x tan x upon x square. A raised to x minus 1 upon x into a raised to 2x minus 1 upon 2x into 2 upon tan of x upon x. Therefore, you will get log of a into again log of a into 2. That is a 2 times a log of a. And therefore, the answer is 2 log of a bracket square. Now the next is limit x tends to a. Sin x minus sin a upon x minus a. Now again here put x is equals to a plus h. Then as x tends to a, h tends to 0. Therefore x tends to a. Sin x minus sin a upon x minus a. This can be written as, that is, here is as h tends to 0. Sin of x is replaced by a plus h minus sin a upon h. So limit h tends to 0. Therefore now apply the formula sin c minus sin d. That is the 2 times cos of c plus d upon 2 and sine of c minus d upon 2. Therefore, you will get a plus a means what? 2a plus h upon 2. That is a 2a upon 2 means what? A plus h upon 2 and sine of a plus h minus a. Now here plus a minus a get cancelled. You will get h upon 2. Now see this here. This is the formula, that sin c minus sin d is equals to 2 times sine of c plus d upon 2 sine of c minus d upon 2. Limit h tends to 0. 2 times cos of a plus h upon 2 sine of h upon 2 h upon 2. Now what's happening here? That is the 2 is adjusted there. 2 will adjust here. That is the sine of h upon 2 upon h. We require the 2. This 2 will come here. Therefore, limit h tends to 2 cos of a plus h upon 2 into sine of h upon 2 upon h upon 2. That 2 is adjusted here. And as h tends to 0, here h will become 0, then you will get cos of a. And the value of this limit, sine of h upon 2 upon h upon 2, the limit is 1. Therefore, 1 into cos of a is equals to cos of a. Therefore, the limit of that function is cos of a. 12th. Now see this again. Limit x tends to a, sin x minus sin a upon x minus a. Put x is equals to a plus h. Then as x tends to a, h tends to 0. L is equals to limit x tends to a, sin x minus sin a upon x minus a. Limit h tends to 0. Sin of x plus a plus h minus sin a upon h. Next is h tends to 0. Apply the formula sin c minus sin d, that is the 2 times cos of c plus d upon 2 sin of c minus d upon 2. Therefore, this leaves, that is the 2 cos of a plus h upon 2 sin of h upon 2. Therefore, limit h tends to 0, cos of a plus h upon 2 into sin of h upon 2 upon h upon 2. This is cos of a into 1, therefore limit L is equals to cos a. L is equals to limit x tends to 2, log of x minus log of 2 upon x minus 2. Again here we will substitute the put x is equals to 2 plus h, as x tends to 2, h tends to 0. Limit h tends to 0, log of 2 plus h minus log of 2 upon h. Limit h tends to 0, that is a subtraction. Now here is a subtraction of the two logs, that is a log of m minus log of n, and it can be written as log of m upon n, that is a 2 plus h upon 2. See this here, limit h tends to 0, log of 2 plus h upon 2 whole divided by h. Limit h tends to 0, log of 1 plus h upon 2 upon h. Here is h upon 2, therefore we also write here h upon 2 into 2 is adjusted there, that is a 1 upon 2 here. And therefore limit h tends to, value of this limit is again 1, 1 into 1 upon 2, overall it is a 1 upon 2. Log of x plus 1 upon x, log of 1 plus x upon x, as x tends to 0, the answer is, the value of that limit is 1. Therefore, L is equals to 1 upon 2. Now see this here, again the same problem, L is equals to limit x tends to 2, log of x minus log of 2 upon x minus 2. Put x is equals to 2 plus h, as x tends to 2, h tends to 0. L is equals to limit h tends to 0, log of 2 plus h minus log of 2 upon h. Therefore, limit h tends to 0, log of 2 plus h upon 2 upon h. Therefore, limit h tends to 0, log of 1 plus h upon 2 upon h upon 2 into 1 upon 2. And value of this limit is 1 into 1 upon 2. Therefore, L is equals to 1 upon 2. L is equals to limit x tends to 1. A b raised to x minus a raised to xb upon x square minus 1. Put x is equals to 1 plus h, as x tends to 1, h tends to 0. Limit h tends to 0. Now here x is replaced by 1 plus h minus a raised to 1 plus h into b upon The value of x is 1 plus h bracket square minus 1. Evaluate this, that is ab b raised to h, ab a raised to h. This is simplification. ab b raised to h, ab a raised to h upon a 1 plus h bracket square minus 1. Evaluate this. Therefore, you will get 1 plus 2h plus h square minus 1. Limit h tends to 0. ab is common. Then you will get b raised to h minus a raised to h. If you take ab common, then you will get b raised to h minus a raised to h. Again, from the common from these two, h is common. Then in bracket you will get 2 in bracket 2 plus h. It's by mistake. Here 2 plus h. Now plus 1 and minus 1 is adjusted here to the numerator. That is a 2 plus h must be there. By mistake it is written. I will change it. Therefore, plus 1 minus 1 is adjusted. B raised to h minus 1 minus a raised to h plus 1 upon h into 1 upon 2 plus h must be there. And add it, change it. Here is h now. AB, first is log of b minus log of a into 1 upon 2 plus 0. Therefore, AB upon 2 log of b upon a. L is equals to AB upon 2 log of b upon a. L is equals to limit x tends to 1. A b raised to x minus a raised to x b upon x square minus 1. Put x is equals to 1 plus h, as x tends to 1, h tends to 0. L is equals to limit h tends to 0. A b raised to 1 plus h minus a raised to 1 plus h into b. And x is replaced by 1 plus h bracket square minus 1. Expand this. Take the common. Then you will get ab b raised to h minus ab a raised to h upon 2h plus h square. Take h as common. Then you will get 2 plus h. Separate it. That is ab is outside from this limit here. Limit h tends to 0. B raised to h minus 1 minus a raised to h plus 1 upon h into 1 upon 2 plus h. The AP limit h tends to 0. B raised to h minus 1 upon h minus a raised to h minus 1 upon h into 1 upon 2 plus h. Therefore, AB log of b minus log of a into 1 upon 2 plus 0. Therefore, AB upon 2 log of b upon a. Therefore, L is equals to AB upon 2 log of b upon a. Number 14. L is equals to limit x tends to 0. 5 raised to x minus 1 bracket square upon 2 raised to x minus 1 log of 1 plus x. Now, here simple thing is that divide n and d by x square. 1x square will be here. 2 raised to x minus 1 upon x into log of 1 plus x upon x. Divide n and d by x square. Limit x tends to 0. 5 raised to x minus 1 bracket square upon x square. 2 raised to x minus 1 upon x into log of 1 plus x upon x. Therefore, limit x tends to 0. 5 raised to x minus 1 bracket square upon 2 raised to x minus 1 upon x into log of 1 plus x upon x. The value of this limit is log of 5 bracket square upon log of 2 into 1. Now, see this here. Log of 5 bracket square, log of 2 into 1. Therefore, log of 5 bracket square, log of 2 is equals to log of 5 bracket square upon log of 2. Again, we'll see here. That is, L is equals to limit x tends to 0. 5 raised to x minus 1 bracket square upon 2 raised to x minus 1 into log of 1 plus x. Divide n and d by x square. Yes, dividing here. That is limit x tends to 0, 5 raised to x minus 1 upon x bracket square. That is in a single bracket. 2 raised to x minus 1 upon x into log of 1 plus x upon x. The value of this limit is a log of 5 bracket square, log of 2. And here is 1 into 1. That is the log of 1 plus x upon x 1. And therefore log of 5 bracket square upon log of 2. Therefore L is equals to log of 5 bracket square upon log of 2 is there. Limit x tends to infinity. 2x plus 1 bracket square into 7x minus 3 bracket cube upon 5x plus 2 bracket raised to 5. Now in this case, limit as x tends to 0, the whole power of the x is 5, therefore divide n and d by x raised to 5. Limit x tends to infinity. 2x plus 1 bracket square, 7x minus 3 bracket raised to 3, 5x plus 2 bracket raised to 5, divide n and d by x raised to 5. Limit x tends to infinity. 2x plus 1 bracket square upon x square into 7x minus 3, 7x minus 3, upon x cube, 5x plus 2 bracket raised to 5x in a single bracket, 5x plus 2 upon x bracket raised to 5. Separate it. Here is the limit x tends to infinity. Here is the divide. 2x upon x, which is 2, plus 1 upon x. 7x upon x means 7 minus 3 upon x in bracket cube. Therefore, you will get 2 plus 0 bracket raised to 2, 7 minus 0 bracket raised to 3, and 5 raised to 5. Therefore, you will get 2 raised to 5 into 7 raised to 1, 5 raised to 5. One more mistake is that here is a 2 raised to 2, not 2 raised to 5. Therefore, it is a 2 raised to 2. I will change it. 2 raised to 2 into 7 raised to 3. That is 1372 upon 3125. Now we'll see that again. See this. Limit x tends to infinity. 2x plus 1 bracket square, 7x minus 3 bracket cube upon 5x plus 2 bracket raised to 5 divided and d by x raised to 5. 2x plus 1 bracket square upon x square into 7x minus 3 bracket cube upon x cube. 5x plus 2 upon x bracket raised to 5. Split up it. Therefore, you will get limit x tends to infinity in bracket 2 plus 1 upon x bracket square into 7 minus 3 upon x bracket cube upon 5 plus 2 upon x bracket raised to 5. Therefore, 2 plus 0 bracket square into 7 minus 0 bracket cube upon 5 plus 0 bracket raised to 5. And therefore, the answer is 1372 upon 3125. That is the final answer. Now the problem number 16, limit x tends to a, x cos a minus a cos x upon x minus a. Now see this here. Limit x tends to a. Put x is equals to a plus h as x tends to a, h tends to 0. limit h tends to 0 in bracket a plus h into cos a minus a cos of a plus h upon h. Now multiplication is a cos a h cos a minus a cos of a plus h cos a cos h minus sin a sin h upon h. Split up it. Then what you will get? That is h cos of a, this divided by h, and for the other terms then a cos a minus a cos h minus sin a sin h. See this here. Now this h get cancelled, limit h tends to 0, cos of a, this is a constant. Now next is a cos a minus a cos a into cos h plus a sin a into sin h. Now we'll split up here. That is a cos a minus a cos a into cos h. Take cos of a as a common. A cos of a is common, divided by h plus a sin a into sin h upon h. Sin h upon h, that limit will be 1, and overall you will get a sin a. And the value of this limit will be 0. Now see this here, how it is 0. Here, cos a cos a is common, 1 minus cos h upon h plus a cos a sin h upon h. Now to evaluate this limit, multiply numerator and denominator by 1 plus cos h, 1 minus 1 square cos square h, then you will get 1 minus cos square h means what? The sin square h. Now here is a cos a, sin square h upon h square, h is adjusted here, into 1 upon 1 plus cos h plus a cos a sin a into sin of h upon h. Therefore, you will get, here is a cos a plus a cos a sin square h upon h square. The value of this limit is 1. But here as h tends to 0, you will get here 0. I forget to write here limit. Here is a 0, 1 upon 1 plus cos of 0 is, here is a 1, and a sin a upon sin h upon h. Here is a limit, sorry, sin of h upon h, that is 1, and overall you will get only the cos of a and a sin a. This is the final answer. Now see this again. Limit x tends to a, x cos a minus a cos x upon x minus a. Limit x tends to a, x cos a minus a cos x upon x minus a. Put x is equals to a plus h, as x tends to a, h tends to 0. L is equals to limit h tends to 0, a plus h into cos a minus a cos of a plus h upon h. Multiply it. Then you will get a cos a plus h cos a minus a. Cos of a plus h means what? Cos a cos h minus sin a sin h upon h. Split up it. A. Therefore you will get a cos a to this term and h cos a upon h. This h get cancelled. A cos a minus a in bracket cos a cos h minus sin a sin h. Therefore h get cancelled. You will get cos a. What about the next? A cos a minus a cos a into cos h plus sin a into sin h. And again from these two terms, by taking that is a cos a as a common, then in bracket you will get 1 minus cos h upon h plus sin a into sin of h upon h. Therefore you will get cos a plus a cos a, 1 minus cos h. Again multiplied n and d by 1 plus cos h upon 1 plus cos h, divided multiplied, plus a sin a into sin of h upon h. Therefore you will get cos a plus a cos a, 1 minus cos h into 1 plus cos h, then you will get sin square h upon h square into h into 1 upon 1 plus cos h plus a sin a into sin of h upon h. Therefore you will get cos a cos a, as h tends to 0, this whole term will become 0. and remaining term is a sin a. Sin of h upon h, the limit is 1, that is a sin a, and hence the answer is cos a plus a cos a plus a sin a. Now again next. Problem number 17. Limit x tends to pi by 4 sin x minus cos x bracket square upon root 2 minus sin x minus cos x. Now again put here x is equals to pi by 4 plus h, as x tends to pi by 4, h tends to 0. Therefore limit h tends to 0, sin of pi by 4 plus h minus cos of pi by 4 plus h, the bracket square root 2 sin of pi by 4 plus h minus cos of pi by 4 plus h. This is the value. Therefore expand this. Now the sin of pi by 4 plus h, sin a plus sin b. Now evaluate this. Sin of a plus b means what? Sin a cos b plus cos a sin b. And what is sin of pi by 4? It is 1 by root 2 into cos h plus 1 by root 2 into sin h. Now see this here. Take 1 by root 2 as a common, then in bracket you will get 1 upon root 2 sin h plus cos h. Next is cos of pi by 4 plus h, then you will get cos of pi by 4 cos h minus sin of pi by 4 into sin h. Therefore you will get 1 upon root 2 in bracket cos h minus sin h. Now the next is sin of pi by 4 plus h minus cos of pi by 4 plus h, separated, 1 upon root 2 sin h plus cos h minus 1 upon root 2 cos h minus sin h. Take 1 upon root 2 overall common, then you will get sin h plus cos h minus cos h plus sin h. Therefore 2 upon root 2 sin of h, that is a root 2 sin h. Overall the value is now the next is sin of pi by 4 plus h plus cos of pi by 4 plus h. Sin of pi by 4 plus h, their expansion. Sin of pi by 4 cos h plus cos of pi by 4 into sin h. Cos of pi by 4 into cos h minus sin of pi by 4 into sin h into sin of pi by 4. Substitute the values. Therefore you will get numbers 1 upon root 2 sin h plus and minus get cancelled. The screen is up and down. That is it. Now see this here. Root 2 sin h bracket square upon root 2 minus root 2 cos h. Take 1 root 2 as a common. Therefore you will get the square of this is 2 sin square h. Take root 2 common, 1 minus cos h. Therefore divide n and dy, h square or sin square h means what? 1 minus cos square h upon 1 minus cos h. Split up it. 1 will get cancelled. Therefore root 2 in bracket 1 plus cos of 0, cos 0 is 1. That is a 2 root 2. This is the answer. Now again see this. Now here is a sin x minus cos x bracket square upon root 2 minus sin x minus cos h. Put x is equals to pi by 4 plus h. As x tends to pi by 4, h tends to 0. Therefore, limit h tends to 0, sin of pi by 4 plus h minus cos of pi by 4 plus h bracket square upon root 2 sin of pi by 4 plus h minus cos of pi by 4 plus h. Now the values of sin of pi by 4 plus h minus cos of pi by 4 plus h, separate it. Sin of pi by 4 plus h, a plus b, by using the expansion of this. Take 1 upon root 2 common, in bracket you will get sin h plus cos h. Cos of pi by 4 plus h, take 1 upon root 2 as common, then cos h minus sin h. Subtract it, sin of pi by 4 plus h minus cos of pi by 4 plus h. 1 upon root 2 in bracket sin h plus cos h minus 1 upon root 2 cos h minus sin h. Take 1 upon root 2 as a common, then plus cos h minus cos h will get cancelled. That is a 2 upon root 2 sin h. Therefore, you will get root 2 sin h. Now the addition of this, sin of pi by 4 plus h plus cos of pi by 4 plus h, separate it, substitute the values. Then 1 upon root 2 sin h minus 1 upon root 2 sin h get cancelled. Then you will get 2 upon root 2 cos h, that is a root 2 cos h. And overall substitute the values. That is a root 2 sin h bracket square upon root 2 minus root 2 cos h. Take root 2 as common. Limit h tends to 0. Sin square h upon 1 minus cos h. Now sin square h can be written as 1 minus cos square h, and then split up it. Cancel it, 1 minus cos h upon 1 minus cos h. Root 2 into, as h tends to 0, it is a cos of 0. 1 plus 1, that is a 2. 2 root 2. Therefore, 2 root 2 is the final limit. Now the next problem is limit x tends to 1, 2 raised to 2x minus 2 minus 2 raised to x plus 1 upon sin square in bracket x minus 1. Now again put here x is equals to 1 plus h, as x tends to 1, h tends to 0. Therefore, limit here is a x tends to 1, 2 raised to 2 in bracket x minus 1 minus 2 raised to x plus 1 sin square in bracket x minus 1. Therefore, limit h tends to 0, 2 raised to 2h, x minus 1 is replaced by h. What is the value of x? X is 1 plus h plus 1 upon sin square h. Now 2 raised to h, 2 raised to 2h minus 2 into 2 raised to h plus 1 upon sin square h. Now this is the perfect square. Now see this here, 2 raised to h minus 1 bracket square upon sin square h. Then divide numerator and denominator by h square. Divide n and d by h square. That is limit h tends to 0. 2 raised to h minus 1 upon h bracket square sin square h upon h square. Log of 2 bracket square upon 1 square. Therefore, the final answer is a log of 2 bracket square. See this here, sin square h upon h square, that is limit h tends to 0 is 1. 2 raised to h minus 1 upon h, this is a log of 2 bracket square. Again, we'll repeat here. Limit x tends to 1, 2 raised to 2x minus 2 minus 2 raised to x plus 1. Put x is equals to 1 plus h, as x tends to 1, h tends to 0. Limit L is equals to limit x tends to 1, 2 raised to 2 in bracket x minus 1 minus 2 raised to x plus 1 upon sin square in bracket x minus 1. That is limit h tends to 0, 2 raised to x minus 1. The value of x minus 1 is h, that is a 2 raised to 2h minus 2 raised to 1 plus h plus 1. And again it is written as 2 raised to 2h minus 2 into 2 raised to h plus 1. Now this is the perfect square of 2 raised to h minus 1 bracket square. That is a 2 raised to h minus 1 bracket square upon sin square h. Therefore, here we will require the h square to the numerator and denominator. Therefore, divide n and d by h square. Therefore, limit h tends to 0, 2 raised to h minus 1 upon h whole square upon sin square h upon h square. The value of this limit is 1 square. Log of 2 bracket square. Therefore, the answer is L is equals to log of 2 bracket square. Now see this. Next is problem number 19. Evaluate L is equals to limit x tends to 1, 4 raised to x minus 1 minus 2 raised to x plus 1 upon x minus 1 bracket square. Now again put x is equals to 1 plus h as x tends to 1, h tends to 0. Therefore, here is the value of limit h tends to 0, 4 raised to h minus 2 raised to 1 plus h plus 1 upon h square. Therefore, limit h tends to 0. Now here is a 4 raised to h means what? 2 raised to h bracket square. 2 raised to 1 plus h means what? 2 into 2 raised to h. Therefore, it is here. Here is the limit h tends to 0. In bracket 2 raised to h minus 1 upon h bracket square, and the answer is log of 2 bracket square. And this is the, now you can see this here. Evaluate this. Limit L is equals to x tends to 1, 4 raised to x minus 1 minus 2 raised to x plus 1 upon x minus 1 bracket square. Put x is equals to 1 plus h. As h tends to 0. Therefore, here h tends to 0 as x tends to 1. Therefore, limit h tends to 0. 4 raised to h minus the value of x is 1 plus h plus 1 x minus 1 bracket square. This is the h bracket square. Now 4 raised to h means what? 2 raised to h bracket square minus 2 into 2 raised to h plus 1 upon h square. Now here is a perfect square. 2 raised to h minus 1 upon h bracket square, which is the log of 2 bracket square. Now the next is limit x tends to 1 root x minus 1 upon log of x. Again put x is equals to 1 plus h as x tends to 1, h tends to 0. Limit h tends to 0. Root of 1 plus h minus 1 upon log of 1 plus h. Limit h tends to 0. Root of 1 plus h minus 1. Multiplied numerator and denominator by root of 1 plus h plus 1. Log of 1 plus h into root of 1 plus h plus 1. Now evaluate this. In root of 1 plus h minus 1 means what? 1 plus h minus 1. Therefore, limit h tends to 0. 1 plus h minus 1 upon log of 1 plus h into 1 upon in root of 1 plus h plus 1. Bracket complete. Therefore, limit h tends to 0. H upon, that is 1 upon 1 plus h upon h into in root of 1 plus h plus 1. The value of the limit is 1 upon, this is 1, 1 upon 1, 1 upon 1 plus 1. That overall you will get 1 upon 2. Therefore, L is equals to 1 upon 2. And the next is series 7. L is equals to limit x tends to 1 root x minus 1 upon log x. Put x is equals to 1 plus h as x tends to 1, h tends to 0. L is equals to limit x tends to 0. X is replaced by 1 plus h minus 1 upon log of 1 plus h. Rationalize it. Multiply n and d by in root of 1 plus h plus 1. Therefore, you will get limit h tends to 0, 1 plus h minus 1 upon 1 log of 1 plus h into 1 upon in root of 1 plus h plus 1. Therefore, limit h tends to 0, 1 upon log of 1 plus h upon h into 1 upon in root of 1 plus h plus 1. As h tends to 0, then you will get 1 upon 1 into 1 upon 1 plus 1. That is equals to 1 upon 2. Therefore, the limit is equals to L is equals to 1 upon 2. L is equals to 1 upon 2. 21. Limit x tends to 0 in the root of 1 minus cos x upon x. f of x is equals to in root of 1 minus cos x upon x. Multiplied n and dy in root of 1 plus cos x, in root of 1 plus cos x. Therefore, you will get in root of 1 minus cos x into 1 plus cos x upon x in root of 1 plus cos x. In root of 1 minus cos square x upon x into in root of 1 plus cos x. That is in root of sin square x upon x into in root of 1 plus cos x. Therefore, sin x upon, this is the mod of sin x upon x in root of 1 plus cos x. Now it is a mod sign. For always the limit does not exist. That is a root mod of sin x is equals to sin x if x is positive, is equals to negative if x is negative. Therefore, we have the two types of the limit x tends to, that is the left hand side limit x tends to 0. In root of 1 minus cos x upon x, that is the limit x tends to, that is minus sin x upon x into 1 upon, in root of 1 plus cos x, the value of this limit is minus 1 into 1 upon 1 plus 1, that is 1 upon 2, that is minus 1 upon 2. This is the left hand side limit. Next is limit x tends to 0 plus, so this is the right hand side limit. That is limit x tends 1 upon in root, the root of, therefore you will get 1 upon 2 plus 1 upon root 2. Therefore, left hand side limit is not equals to right hand side limit, hence the limit does not exist. Therefore, limit x tends to 0 in root of 1 minus cos x upon x does not exist. Let's see this again here. In root of limit x tends to 0 in root of 1 minus cos x upon x. Multiplied n and dy in root of 1 plus cos h. Therefore, in root of 1 minus cos h into 1 plus cos h upon x in root of 1 plus cos h. In root of sin square x, x in root of 1 plus cos x. F of x is equals to mod of sin x upon x in root of 1 plus cos x. Now, sin of mod of sin x is equals to sin x if x is positive, is equals to minus sin x if x is negative. And solve this limit. Therefore, the first is minus 1 upon 2. About the second, right hand side limit, it is a plus 1 upon 2. Therefore, from 1 and 2, the left hand side limit is not equals to the right hand side limit, and hence the limit does not exist. (22) Limit x tends to minus 1, 1 plus 3x square plus 5x cube plus dash dash in bracket 2n minus 1 x raised to n minus n square upon x minus 1. This is a big problem. Limit x tends to minus 1. Now see this sequence. There is a minus n square and it is written as like this, 1 plus 3 plus 5 dash dash up to 2n minus 1 upon x minus 1. Now the value of that n square, that is 1 plus 3 plus 5 plus dash dash plus 2n minus 1, and summation of this is nothing but this is in AP and its summation is n square. Therefore, it is written as in this manner. That is 1 plus 3 plus 5 2n minus 1 n upon 2 in bracket 2a, that is 2 into 1 plus n minus 1 into 2, that is equals to n square. Therefore, limit x tends to minus 1, 1 minus x, 3x square minus 3 plus 5x square minus 5 plus dash dash 2n minus 1 x raised to n minus 1 upon x minus 1. That is, if we take the 5 common, 3 common upon x minus 1, split up it. You can see this here. The value of this limit is 1. Apply the formula. Limit x tends to minus 1, x square minus 1 upon x minus 1. Find bracket x cube to n minus 1. Therefore, this is the 1 raised to 1 minus 1, 3 into 2, 1 raised to 2 minus 1, plus 5 into 3, 1 raised to 3 minus 1, plus, in bracket 2n minus 1 into n, 1 raised to n minus 1. Therefore, 1 into 1 is 1, 3 into 2, 5 into 3, plus, in bracket 2n minus 1 into n. And this is nothing but the summation r is equals to 1 to n. That is, first is 1, 3, 5, and next is 1, 2, 3. Therefore, overall summation r is equals to 1 to n, 2r minus 1 into r. Therefore, r is equals to 1. Take 2 as common. That is a 2r square minus r. Take 2 as common. That is a r is equals to 1 to n, r square. Next is summation of the r. That is a 2 into summation of r square means what? N into n plus 1 into 2n plus 1 upon 6. And summation of r is n into n plus 1 upon 2. Therefore, 1 upon 3, n into n plus 1 into 2n plus 1 minus n into n plus 1. But take the common, n into n plus 1, 2n plus 1 upon 3 minus 1. After simplification, you will get n into n plus 1. And next is a 4n plus 2 minus 3 upon 6. Therefore, n into n plus 1. 4n minus 1 upon 6. Now, see this again here. Minus n square. This n square can be written 1 plus 3 plus 5 plus dash dash 2n minus 1. Now this 1 will come here, x minus 1. This 3 will come here, 3x square minus 3, 5x cube minus 5. And again 1 plus 3. Why? This is n square means what? N square means 1 plus 3 plus 5 plus dash dash 2n minus 1. How it is? 1 plus 3 plus 5 plus 2n minus 1. This is nothing but the AP, whose first term is 1, common difference is 2, and their sum is n upon 2 in bracket 2a plus n minus 1 into d is equals to n square. Therefore, limit x tends to minus 1, x minus 1 plus 3x square minus 3 plus 5x cube minus 5 plus dash dash plus 2n minus 1 into x raised to n minus 1 upon x minus 1. Split up it. Then you will get limit x tends to minus 1, x minus 1 upon x minus 1 plus 3 in bracket x square minus 1 upon x minus 1 plus 5 in bracket x cube minus 1 upon x minus 1. And in this way, the last term is a square. Now, the individual limit. The first is 1 raised to 1 minus 1. Second is 3 into 2 into 1 raised to 2 minus 1. Third is 5 into 3 into 1 raised to 3 minus 1 plus dash dash plus 2n minus 1 into n into 1 raised to n minus 1, 1.1, 3.2, 5.3 plus 2n minus 1 into n. That is r is equals to summation r is equals to 1 to n in bracket 2r minus 1 into r. The summation 2 in bracket r is equals to 1 to n r square minus summation r is equals to 1 to n of the r. Therefore, you will get 2. Summation of the r square is n into n plus 1 to n plus 1 upon 6 minus n into n plus 1 upon 2. And after the evaluation, you will get n into n plus 1 in square bracket 2n plus 1 upon 3 minus 1 upon 2. And their simplification is nothing but the n into n plus 1, 4n minus 1 upon 6. Now the next problem number 23. Limit x tends to 0, 1 upon x raised to 12. 1 minus cos of x square upon 2, 1 minus cos of x raised to 4 upon 4 plus cos of x square upon 2 into cos of x raised to 4 upon 4. Now consider the first, the terms, that is a 1 minus cos of x square upon 2 minus cos of x raised to 4 upon 4 plus cos of x square upon 2 into cos of x raised to 4 upon 4. Now from take the first two terms, and from the remaining two terms takes cos of x raised to 4 upon 4 as a common. Therefore, in bracket we will get 1 minus cos of x square upon 2 and 1 minus cos of x square upon 2. Take 1 minus cos of x square upon 2 as a common. Then in bracket you will get 1 minus cos of x raised to 4 upon 4. Therefore, one minus cos of x square upon 2 multiplied here numerator and denominator by 1 plus cos of x square upon 2 upon 1 plus cos of x square upon 2. 1 plus cos of x raised to 4 upon 4 and 1 plus cos of x raised to 4 upon 4 multiplied and divide. Therefore, you will get 1 minus cos of x square upon 2, 1 minus cos of cos square x raised to 4 upon 4. Net here must be the square sign, I think. 1 plus cos of x square upon 2, 1 plus cos of x raised to 4 upon 4, means a square must be there. Now, here is a sine square x square upon 2 into sine square x raised to 4 upon 4. In bracket 1 plus cos of x square upon 2, 1 plus cos of x raised to 4 upon 4. Therefore, now we take the limit. Sine square x square upon 2, sine square x raised to 4 upon 4 in bracket x raised to 12 into 1 plus cos of x square upon 2. Next bracket 1 plus cos of x raised to 4 upon 4. Now here is limit x tends to 0, sine square x square upon 2 into sine square x raised to 4 upon 4. Now here you will get x raised to 4 upon 4 into x raised to 8 upon 16 and the remaining brackets keep it as it is. Adjust is here 4 into 60, that is 64. Therefore, we have written 1 upon 64. Therefore, the limit is 1 upon 64, limit x tends to 0. Sine of x square upon 2, x square upon 2, bracket square into limit x tends to 0, sine of x raised to 4 upon 4, x raised to 4 upon 4, full bracket square. And limit x tends to 0, 1 plus cos of x square upon 2, limit x tends to 0, 1 plus cos of x raised to 4 upon 4, and 1 upon 64, 1 square, 1 square, 1 plus 1 into 1 plus 1, that 1 upon 64 upon 1 upon 4, that is 1 upon 256. Now, let's see here, consider the terms. 1 minus cos of x square upon 2. Now, from this term, we are taking the common cos of x raised to 4 upon 4, 1 minus cos of x square upon 2. From these two terms, we take the common 1 minus cos of x square upon 2. Then you will get 1 minus cos of x raised to 4 upon 4. Next is multiplied n and d by 1 plus cos of x square upon 2 and 1 plus cos of x raised to 4 upon 4 n and d. Then you will get, here is a, now I will change here, that is a 1 minus, here is a 1 minus cos of x square upon 2 into 1 plus cos of x square upon 2, it becomes 1 minus cos square x square upon 2, 1 minus cos square x raised to 4 upon 4. Now this is the sin square x square upon 2 into sin square x raised to 4 upon 4 upon 1 plus cos of x square upon 2 into 1 plus cos of x raised to 4 upon 4. Limit x tends to 0, sin square x square upon 2 into sin square x raised to 4 upon 4. upon x raised to 4 in bracket 1 plus cos of x square upon 2 into 1 plus cos of x raised to 4 upon 4. Now it is a sin square x square upon 2. Therefore, the square of this is x raised to 4 upon 4. And the square of this is x raised to 8 upon 16. And the remaining. What's the term is adjusted here? 4 into 16 is 64. That is the 1 upon 64. Now here is a limit. It is written 1 upon 64. Limit x tends to 0. Sin of x square upon 2 upon x square upon 2 whole square plus that into limit x tends to 0. Sin of x raised to 4 upon 4 upon x raised to 4 upon 4 whole bracket square. Now the limit of this is 1 square, and the limit of this is 1 plus 1, 1 plus 1. Therefore, 1 upon 64, 1 square into 1 square. Cos 0 is 1. That 1 upon 64 upon 1 in bracket 1 plus 1 into 1 plus 1. Overall, you will get 1 upon 64 into 1 upon 4. That is nothing but the 1 upon 256, and hence the limit is 1 upon 256. Now, next is now the 24, limit x tends to infinity. 8x square plus 5x plus 3 to x square minus 7x minus 5 and whole bracket is to 4x plus 3 upon 8x minus 1. We will take here divide n and dy x square, find out the limit of this, and divide n and dy x, find limit of this, and whatever the limit come here, this raised to this. That is the final answer. Now see this here. Limit x tends to infinity. 8x square plus 5x plus 3. 2x square minus 7x minus 5 raised to 4x plus 3 upon 8x minus 1. Divide n and dy x square. If you divide, then you will get 8 plus 5 upon x plus 3 upon x square. 2 minus 7 upon x minus 5 upon x square. Therefore, you will get 8 upon 2, that is equals to 4. Next is the limit of exponent g of x. Or we take the limit x tends to infinity. 4x plus 3 upon 8x minus 1. Divide n and dy x. Therefore, you will get that is 4 plus 3 upon x, 8 minus 1 upon x, and that is 0, 0 is a 4 upon 8, that is equals to 1 upon 2. Therefore, limit x tends to infinity. 8x square plus 5x plus 3, 2x square minus 7x minus 5, whole bracket is to 4x plus 3 upon 8x minus 1, and therefore it is a 4 is to 1 upon 2. Therefore, it is equals to 1 upon 2. This is the final answer. In this way, we have completed the miscellaneous exercise for the limit. I will see in the next video. Till then, goodbye. Now see this again here. The same problem. Divide numerator and denominator by x square for this term. But taking this term. The answer is 4. And their exponent, that is the 4x plus 3 upon 8x minus 1. N and dy x, you will get 1 upon 2. That is 4 is to 1 upon 2. The limit of this is a 4 and bracket is to 1 upon 2. Therefore, you will get 4 is to 1 upon 2, that is equals to 2. Therefore, it is equals to 2. Now, in this way, we have completed the miscellaneous exercise for the limit. Now, we'll see in the next video for the continuity. Till then, goodbye.